Evening everyone. Good evening everybody. So welcome to my next class. So where we'll be discussing the concept of dipole moment. So obviously I am talking about electric dipole moment and the relationship between potential and dipole moment. So first of all, what do you mean by electric dipole? So electric dipole is nothing but the combination of two equal and opposite charges separated by a very small distance. So suppose take for example so two equal, let it be plus q and this one is minus q. So this separation is very small, very less. So let the distance be L. So it becomes, the middle one becomes, this distance will be L by 2. So this will be L by 2 and it will be L by 2. Let P is the point of interest where we are going to find out the potential due to the two charges. Now let us connect this point to here and the middle one to here and this one to. Now you see, suppose drop a perpendicular here from this one, drop a perpendicular. So this is 90 degree, this is 90 degree. So let it be theta. So this one will also be theta. Now having said that, I want to tell you the point of interest in comparison with the distance between the two charges is very much large. That means this R is much greater than L. Now whenever we are going to drop a perpendicular here and this angle is theta, this angle is theta, so this one is suppose R1, so it will be nothing but this component will be, this horizontal component will be L by 2 cos theta. So R1 will be R minus L by 2 cos theta. Whereas this one will be, this R2 will be R plus L by 2 cos theta. Now whenever we are going to find out, let's take the potential at point P due to these two charges. So potential at point P due to these two charges, let it be V is equal to Q by 4 pi epsilon R1 and due to the negative charge it will be Q by minus Q by 4 pi epsilon R2. So this will give you V is equal to, we can take this Q by 4 pi epsilon common, so it will be 1 by R1 minus 1 by R2. So this one will be, again you can write, so V is equal to Q by 4 pi epsilon into R2 minus R1 divided by R1 into R2. Now let us put the values. So this gives you V is equal to Q by 4 pi epsilon into R2 minus R1. So we have written the values. R2 is equal to R plus L by 2 cos theta minus R1, it will be minus R plus L by 2 cos theta divided by R1 into R2. So it will be R minus L by 2 cos theta into R plus L by 2 cos theta. Now you see this R and this R get cancelled. So we get V is equal to Q by 4 pi epsilon into L by 2 cos theta plus L by 2 cos theta. It will be 2 into L by 2 cos theta. So it will give you L cos theta divided by R square minus L square by 4. So this will be cos square theta. A square minus B square. A minus B into A plus B. So it will be R square minus L square by 4 cos square theta. So as we have taken that R is, as we know that R is much greater than L. So the L is very less in comparison with R. So that this factor will be neglected. So let us take this one to be 0. So you are getting V is equal to Q into L into cos theta divided by 4 pi epsilon r square. This Q into L is nothing but dipole moment. So dipole moment is a vector that will be in the direction of the distance vector. So that is the relationship between the potential. V is the potential. So potential is equal to, so this one is the dipole moment, Q into L, that is the product of the charge into this length between them, into cos theta, that is the angle factor, divided by this potential we have derived that is equal to dipole moment into cos theta by 4 pi epsilon r square. So if we are going to find out the dipole moment, so the dipole moment is equal to Q into L. I am writing it here. So let me write down here. So with this we are ending this one. In the next class we will be coming with other videos. So thank you all for watching. Please like, share and subscribe to my channel. Thank you all.